We saw in the lesson on antennae that a loop antenna is used to detect the direction from which a signal is transmitting. It does this by comparing the strength of signal on the two sides of the antenna. Where there is no difference in strength, the signal is either 90 degrees in front or 90 degrees behind the antenna. This direction finding system, called VHF Direction Finder, or VDF, is available in many airfields, and a pilot can ask a ground station to give him a bearing to fly to the station. The ground station uses this loop antenna theory to locate the aircraft by taking a bearing on its VHF transmissions. UHF transmissions are also used, but only by the military. The equipment used is now far more sophisticated than the old loop antenna, and the antenna used is called an adcock antenna. This has 4 or more vertical elements, vertically polarized. Here we have an array of elements, which are arranged in a circle. The bearing obtained, using the Doppler principle, is displayed either on a cathode ray tube or as a digital readout. Accuracy can be as good as plus or minus half a degree. Four types of service are provided by the ground station, depending upon the request from the pilot. The services have the following designators. QDM, this gives the magnetic track to the station. QDR, this gives the magnetic bearing from the station. QUJ, this gives the true track to the station, and QTE gives the true bearing from the station. When a pilot wishes to obtain a bearing from a ground station, he calls up on their frequency and requests the appropriate service. For example, the QDM would be requested when the pilot wished to fly a magnetic track to the station. He would say, QDM, QDM, QDM Oxford Approach, Golf Lima Oscar Romeo Tango, request QDM Golf Romeo Tango. Notice that the reciprocal, that is the opposite of QDM, the magnetic track to the station, is QDR, the magnetic bearing from the station. Similarly, the reciprocal of QUJ, the true track to the station, is QTE, the true bearing from the station. If you want a track to fly, you would ask for a magnetic bearing, that is, the QDM or the QDR. But if you wanted to plot your position on your chart, for example, to know where you were in relation to a danger area, you would request a true bearing, as charts are oriented to true north. The bearings given by the ground station can be very accurate, especially if Doppler principles are used. A simple classification system has been devised for bearing accuracy, namely, Class A, accurate to within plus or minus 2 degrees. These are not available in the UK. Class B, accurate to within plus or minus 5 degrees. Class C, accurate to within plus or minus 10 degrees. And Class D, accurate to within more than 10 degrees. A further use of the VDF system is to provide a letdown service where there are no other aids, such as an NDB or ILS. There are 2 types of VDF procedure, QDM and QGH. In the QDM, the pilot calls for a series of QDM and uses them to follow the published approach pattern, making his own adjustment to heading and height. In the QGH procedure, the controller obtains bearings from the aircraft's transmissions, interprets this information, and passes to the pilot headings and heights to fly designed to keep the aircraft in the published pattern. Normally, at civil aerodromes, only the QDM procedure is available. A refinement of the VDH service is the VHF emergency service on 121.5 MHz. A network of stations across many countries is able to provide a location service by triangulation for aircraft in distress, in urgent need of assistance, or which are lost. With the widespread use of GPS, most pilots know where they are, but GPS can fail, run out of batteries, be mishandled or misinterpreted, and pilots can become too reliant upon it. VDF uses the VHF frequencies of 117.975 to 137.0 MHz. Remember these because it is a popular exam question. Several factors affect the range of VDF transmissions. As VDF utilizes the VHF band, or sometimes the UHF band, the range in nautical miles will obey the line of sight formula of 1.23 times the sum of the square root of the height of the receiver in feet and the square root of the transmitter in feet. So the higher the aircraft, the better. Intervening high ground will limit range, especially for low-flying aircraft in hilly terrain. High ground and buildings at the station may also reflect and distort signals. The power of the aircraft and ground transmitters will also affect range. The weather, on the other hand, can sometimes increase range. If there is a marked inversion and a rapid decrease in humidity with height, signals may be ducted below the inversion, resulting in an increased range. Several factors will affect the accuracy of the bearing. Synchronous transmissions by two or more aircraft will result in a bearing accuracy somewhere between the values for each aircraft. As VHF waves are vertically polarized, the aircraft should fly straight and level to produce the best signal. Accuracy will also be poor at low level or near a position overhead the adcock antenna. These are the important points to remember. VDF uses the VHF frequencies of 117.975 to 137.0 MHz. Remember the Q codes for the various types of bearing. The approach procedure can be a QGH or a QDM-based VDF letdown. Remember the accuracy figures and that an auto-triangulation service is available in the UK on 121.5 MHz.